So hello everybody, thanks for being here to listen to Christophe Aubertin. He's a French architect working in Studiolada, architecture studio in Nancy, near Nancy in the east of France. And he's also at the same time teaching at the architecture faculty in France. He has been building a lot of stone building, and not only stone, but stone and timber together to make a beautiful building using mostly local stones, local timber. So reducing the footprint of the building and the carbon emission of the building. So it was really interesting. I discovered his work during another event on stone construction, and I was really impressed by his work. So that's the reason why I decided to invite him for this class. And I really hope he will help you to understand what can be built in stone. Thanks a lot, Christophe, for being here. And we are listening to you.
Okay, thank you very much. So hello, everybody. Nice to meet you. Very happy to be here to talk about stone construction with you. First, excuse my English because I don't speak very often in English and I am not very fluent. But okay, so I'm very happy to talk about stone construction. I think it's very important because of footprint, because of sustainable architecture. This is a very necessary now to find alternative to concrete. I think the world now we all build in concrete everything in the world with steel and concrete, and I think it is really necessary now to find other way to build. And so wood construction is coming since several years, and it's going to be quite usual now. But we need to develop other kind of construction, and like massive and mineral construction instead of concrete. So we need to develop stone construction and earth construction. It is very important. And stone construction is something that everybody forgot, but now it comes again. It has to be think again to find new way to do, find new way to make it cheap, economic, and it has a real future, I think, because everybody loves it. Everybody loves stone. And it makes very strong building. So it is important. And also in Turkey, you get a lot of stone in your country. So it is very strategic, I think, to learn about how to build in stone. So I will share my screen. It's here. Okay, so I will, I don't will explain you how can I say, all the way to build in stone. I just will explain some buildings that we do with stone in France. And also there is many way to do. I think one way important for me was the example of Gilles Perrodin. Maybe you know this guy. He is a French architect, and he built and he gave a new birth, a new way to use stone in contemporary architecture in France. But he has a way to build with very big pieces of stone, like 2 meters, 1 meters, and 50 centimeters, and he used this way. And sometimes it's possible in his area, but sometimes it is not possible to use such big quantity of stone for us, it is not possible to use such a big quantity because of the price and because of the stone that we get. So we try to find other way to use stone. And I will, so this is, for example, the map of France. And here you can see the different area where you can find stone and the different kind of stone that we can get. And here you get, for example, limestone in yellow, sandstone, granite. So you have different kind. I live here in this area. And what I like to do with my partner in architecture, we love to use the resources and the material that we can find in an area to make the architecture. For example, if I'm here, I use limestone, here sandstone, here granite, and also for the timber, we change the material, the resources according to the area where we build. And this is for footprint and sustainable condition, but it is also because I think that it's interesting to don't have the same architecture everywhere and to find different cultural and different design material according to the area where you are. So, for example, we build one building here and one building here in Vaucouleurs, and we use limestone from this carrier very close from to build this one. For this one, another building in the same area, we use this stone. So all this is very close, but these three buildings use limestone like white stone. This one is in the north where there is a special limestone with a yellow color. So my partner Benoit built this building with this yellow stone. And here it is another area. We are here, and here we use this stone. This is sandstone, pink sandstone, to build this building. Okay, so. So the first building that we did with stone was this one. It was 10 years ago, and it was health center in a village in France. So with for doctor and nurse and this kind. And we were in the area of limestone. We decided to make to mix the timber and stone. So we decided to put the timber outside. So wall, like a frame, balloon frame wall structure outside with a lot of insulation, and to get the stone inside. So inside we just have this big wall like this, linear, built with stone blocks. And also the floor here, which is covered by tiles, stone tiles. So it's interesting to get the stone inside the building because we don't have to put insulation on this wall, so we can see it on the two faces. It's beautiful. It's quite expensive, so we prefer to see it in the two faces. And also it is interesting for the thermical way, because when you have massive blocks inside, it keeps the thermical ambient inside. So it makes like inertia, I don't know the term, but it makes like, it keeps the heat or the cold inside.
Inertia.
Inertia, yeah, that's it. So this is our wall. First, we wanted like a wall like Gilles Perraudin, like 50 centimeters thick, but it was too expensive. And the good equilibrate was to take 22 centimeters. So we use this. In the bottom, we put 2 ranks of cellular concrete, because of the cold, it cut the cold coming from the floor, from the earth, and it cut the cold to come inside the wall. So that's why there is these two ranks of cellular concrete. And then it was really simple. We put these blocks, and on it we can put these big beams in wood, in timber coming on it, and the wall in stone carry the beam in timber. This is important. And one thing important here, we were not in a seismic area, okay? But even in France, even in non-seismic area, the new rules tell us to put like reinforced concrete in many places in a wall like that. So usually you have to put like concrete inside the wall here. So you do a hole, and then you put concrete and steel inside. And but in this wall, we could talk with the guys to check the normative things, and he accepted that this wall was only in stone. And we had also guys to build this wall that are used to historical building, and for them it is not necessary to put steel. So this is only stone blocks like this, and this is the way that we finish the building with this material that is very important, interesting. This is another view with a big beam in stone here. We cannot see very well, but you have this kind of way to build. One block on the column, one other block here, and then 1, 2, 3 blocks with this kind of shape, and it makes like an arch, but a flat arch coming from this part to this part, then to this part, then to this part. And here it is a furniture. Here it is not carry on. The stone doesn't carry anything, so it is like a wood furniture. And then we put some stone, 8 centimeters stone, to just on the facade of the furniture. And one thing important here, we try for the first time to use stone tiles on the floor, and we discovered this stone tiles from Bourgogne, and we realized that it's quite economic. This kind of stone, there was like 3 centimeters thick, and this is quite economical. I say that for the next project. So the next project is in the same territory, in the same area, like 15 kilometers far from the first one, and it is building for retired people. And here it is just an extension for the big retired center. And here we decided to use stone again, because we are in the area of stone, and there are some carrier. And we decided to build in wood. And also the director of the client for the users of the building told us that they don't want wood clad outside of the building, because they don't like how timber will get old and get gray and all that. So we decided to do the opposite of the first one, and to put only wood and timber inside, and to put the stone outside with only clad. So this is stone clads, but coming on a wall with a structure in a timber. So this is not simple. This is particular because we just can, usually you can put stone clad only on concrete walls, because concrete walls are very strong and very they don't move. A wall in concrete don't move at all. But a wood in a wall with timber structure always moves just a little bit, but this movement can make a problem for the stone, because it can make a torsion and it can break the stone. So we had to propose this way. So this way is quite simple. It's only to put wood columns on the walls with two little pieces of wood, and we put the tiles, the stone tiles, inside this small place like this, and that was not common. So we had to prove it and make a special certification to explain how to do it. With you see this black thing is a joint in EPDM. I don't know how to tell it. It's kind of plastic, but a kind of joint to maintain the stone and to be sure that it will always be maintained and to don't get problematic. And this small piece of steel to carry also the stone. So this guy is on the way to put the stone, and then we get this kind of architecture. So we have a wood building, but outside we get the stone tiles on the facade with these lines. This is very important. These vertical lines in wood. And I think that this kind of facade is very interesting, and everybody was happy, even the users that don't like wood. This kind of solution with like 10% of wood and 90% of stone is a way that everybody loves. It's only natural materials, and it will get old very well. So that's why it was interesting for us to try that this way. So you see that you get small join to get the ventilation coming backside of the stone, and to be sure that there is not humidity, water coming in the wall like that. So that was a way to use stone also in a economic way, pragmatic, easy way. So we just use it it was 4 centimeters thick. So it is this kind of clad was not very expensive. Then the third building was another one. So we changed the area. We are in the mountain, and the mountain we get this sandstone, a pink sandstone. And this building is a tourism office, so to inform tourists about what they can visit, what they can do, also the natural area of this territory. And we wanted a building that has a special architecture, like make a signal. So we decided to put it to do it in a circular form, circle. And since the very beginning, we decided to do it in stone and with a circular form. And this is the only idea of this building, is to use blocks and to make them in a curved ways. So it makes this kind of small I don't know how to express it, but it's kind of I don't know, of shade and of a pattern. And so we have been in a carrier really close from there, and to tell this guy we wanted to build with sandstone. They say, okay, we can build with you, and we wanted big blocks. And they explain us that the bigger block that they can provide is a block that is 140 centimeters long and 35 per 35 centimeters from thick. So this kind of blocks was the module, was the block, the unity. And then we designed this this shape. It's very simple. There are 10 ranks. I don't know if so there are 10 ranks of stone, 10 per 35, so it is 3 meters and 50 high. Then you get the plan, and we have 32 blocks, 8, 8, 8, 8, like that. And then you have some part where you got columns, so you have half blocks. So it is really really geometrical and simple to design. You have part with insulation. So we are in the mountains. It's cold weather, so we get insulation everywhere. And we have this part where it's just covered, but outside. So here you can see the stone outside and inside. So it is also the same way that for the first one. We know that stone is quite expensive and very beautiful. So we try to show it, to make it visible the most as possible. This is the structure for the wood carpet. So very simple, flat roof with just a small slope. And here you get 7 ranks of stone, 35 centimeters, and 3 ranks more thin. So you can get the timber beams coming here in this simple way. And here it is concrete like that. And also on the top, we wanted to get the stone until the top. We didn't want to get this metal sheet to protect the top of the roof. So we decided to have stone blocks like that to protect the top of the wall. And this is the way to build, so quite fast and easy with the mechanical way to take the blocks. And this is the building. Also, the floor on the pavement in front of the building, all the floor is made with small pieces of stone, which are like 10 per 10 per 10 centimeters size. So it's like this. Here you can see the stone on the top and the 10 ranks, like this. And inside, everything is built is in wood. It is like a very opposite ambient. Outside only stone and inside only wood, and the heat and this feeling to feel hot and comfortable. Also, you say to talk about seismic part. So in this building, the circular form was a good point for the seismic problem. Here we have a seismic problem in this area. So the first thing was that circular shape was a good thing, and we get negotiation with the guys, and they accept to only have concrete inside the columns. So here you do a a carrot, you do a hole 10 centimeters of 15 centimeters diameter, and on the whole height of the columns, and then you put some steel and then concrete, so it reinforces these columns. So every columns get this, and also when you get the wall, so you don't need reinforcement vertical in the wall, but only on the extremity. So here, 1, 2, 3, 4. Here we did the same that in the column. We put concrete and reinforcement. And also horizontal reinforcement. It doesn't appear here, but we get one here. We did a reinforcement in the join. So we make a thick join. Instead of 5 millimeters, it is 2 centimeters here. And in the mortar, we put some steel grid coming inside to make like a circular and horizontal reinforcement. So there is one here and also one at the top of the building, just down to the stone. So you will see it. You will see it here. If you look at it, it's just here. It is more thick. So here there is a reinforcement instead of this only 5 millimeters, and also here. Here it is more thick, and you get the metal grid. So this is some ways to put this reinforcement without putting too much concrete. Otherwise, if you listen to the normative advices, you just build like a grid in concrete, and then you put a little bit of stone inside the grid. But we don't want that. We really want to build stone walls. Okay, so the next project is this one. We are building this one at this time. The first stone blocks will come very soon on the area. So it is a market, a municipal market in a city called Saint-Dizier. And for the competition, we propose to build it in stone, because this is an historical city where a lot of buildings are built with this stone, very limestone, very beautiful, very classical. But we wanted to make a contemporary modern building using the same stone than the historical one. And we wanted to make arch. So that was very important for me. I love the design of the arch and the vaults and all this traditional way to build with blocks. It can be stone blocks, it can be bricks, it can be bricks, but I really love this way to use curves and to use this kind of shape to make buildings. So this is arch, and I hope that one day I can build a building with a vault. I think it's important to talk with you about that, because I think in Turkey you still get some builders who knows this traditional way to build that. And I think it's important to know these guys and to build with them and to do not forget this kind of know-how. Very interesting. So this is big blocks, and we wanted a big arch. Here it is 24 meters with a big arch, and then on this facade we get small arch. And inside we have a big carpet in wood. So that is the all that I love is to mix stone or earth and wood. And wood is quite cheap, and we can do that easily. So concerning the arch, so we knew this big arch on this project, a project from Renzo Piano in Italy, the Padre Pio Church, where they use this kind of very big blocks and big arch with stone. But it is a quite technological way. So you have like a lot of steels components with steel board here, and then they put blocks inside and they do that. And then from the steel's board, they can put these steel pieces to carry the roof of the building. Okay, so you get the stone and steel mixing, making the structure together. And we have this kind of guys. So this is very close from our area. I didn't know this this firm before, but I knew from some friends, and we came to visit their buildings. And these guys are stone builders, and they love stone, and they build their building like some years ago, and they make this big arch with stone. So this is concrete blocks here and here, and then it is stone blocks with a very special shape, and then they can do it like that in a very traditional way. So it's only blocks. And this is the key, I don't know, the key of the vault coming on the top. And when you put that, everything is maintained. You know, to build that, you know this traditional technique. You do a wooden gabarit, a wooden structure to maintain during the time that you build. So you put all your stone on the wood structure, and then when you put this one, you take off the wood shape, and then it is maintained by itself. And then you take the wooden structure and you build the second arch, then the third, then the fourth, and you can use it for the other one. So that's why we think that, okay, we have a firm very with a know-how important, and they can build our building. So let's try to propose a stone building with this particularity with these arches. So this is the plan, very simple of the market. Big arch here and here, middle, 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 small, middle, middle, small, and the same here. So that was the facade that we designed for the competition. It was quite speed for the competition, so we decided to do this kind of shape. So this is parabolic shape, and that was a basket handle shape for this one. That's what we thought. And then we changes during the study. So after we won the competition, we designed it more precise, sharp, and we did this design. So the big one, and middle, 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 and the small. And here we changed the shape of the big one, and they all are the same arch. They all are parabolic arch. Parabolic with a small dimension, middle, and large, but it is the same way to do it. And so you get concrete here, the arch, and then you get stone here, but this is only stone blocks horizontal coming on the arches. This wall is 60 centimeters wide, and this wall is 40. And we are happy also because we we scared to need to get steel inside the arch. That would have been possible. It could be necessary, and but we could explain and calculate to say that we don't need steel, and we are very happy to do that only with stone blocks in a very simple way and traditional way. But and then we have concrete blocks here, and we cannot see it, but we have a very important beam in the ground here in concrete with a lot of steel inside to maintain the traction, the pushing of the stone here. And here you have a beam in tension. Okay, and so that is the design of the building. So you can see all the blocks with this repertoriate, and that's it. Here the big one. And then that was the first block that they cut with this shape. They use curved shape like this to minimize the what do you say? So it cannot whip. It cannot. There are more contacts between the two stones. So that's why we use this kind of shape. And we have been like 3 weeks, 1 month ago to visit the firm. So now they cut like the whole quantity of the blocks. They are here waiting for the work in progress. And this is the wood they are going to make the shape with these pieces of wood. And this is the big blocks. And here there is this hole here at this part. It is only to carry the block and to put it in its position with the machine to carry the block. And this is the exact equilibrate the equilibrate point. So when you get the block maintained here, you can move it very easily to put it with your hand to put it in the good shape. That's why they do that. Okay, and that is another one, another project. I don't know. Yes. Okay. So this is another building to finish that we are working on it now. This building, we had to build it after that I meet like last year's. I've been in London for this exhibition, the New Stone Age, so the new way to build with stone. And they asked me to present the circular building, the pink circular building. So I've been there, and there I met some guys. I met the curators of the exhibition. I met Pierre Bidot from the Stone Masonry Company. So they are a firm, a company building with stone. And I met also these engineers, structural engineers, Steve Webb, and also this architect, Amin Taha. And we had good, many things to share. And after that, the Stone Masonry Company wanted to build a new building for the firm. And so they asked me to work with them and the engineer, Steve Webb, to build this structure. And when we have been to the exhibition, they make that, they put that on the front of the building. So you can see that is very important, and it is not common. It is a very big beams. You see it's like 12 meters, and it is only made with stone blocks like this, stone blocks like this. Okay, so you make these beams, and you put all the stone blocks near to the others, and then you have steel cables going all around the beam, coming from this part to the other one. Then you have a board, a steel board, and then you make it very strong. You make it to maintain the stone blocks. And like this, with this 3 cable of steel, you can have these big beams. And this is very interesting because you make a kind of concrete beam, but with stone. And you can see that for 12 meters, you only have 60 centimeters high. And so this is very performance on economical beam. So very nice. I was amazed and interesting by this technique. And then they proposed me to work with them for their own building using this technique. So you can see this structural portico with columns and beams like that. And so everything is maintained with these steel cables inside and stone. And so you just have 25 centimeters large and 55 centimeters, I think. So you can get these beams like that. And I'm very happy to build one of the first buildings using this technology in an economic way, in a cheap way, and very that you can use again. You can reproduce this technique. So this is the details from Steve Webb about this technical. And here it's interesting because you get the columns. Here you can see the cable, the steel cables, and here, so the vertical one, the horizontal one, okay. And this piece is more important. You get more strong problematic inside. So this stone has to be stronger. That's why they use granite node for this piece, and this is in limestone because granite is stronger. So you just put granite at this part, and this is very logical and simple way. So you get granite here, limestone, granite, limestone, and we can propose a new way to make structure with quantity of material, of stone material, very light. So it can be done with small budget. And then to continue and explain how we build, how we will build. So we didn't start to build it, but we will build the building. So we get the 5 portico in stone, and then we put wood panels with insulation to make the facade everywhere like this. So big panels. We do also the floor and the walls inside, the stairs, everything. And then we do the whole shape of the building, and then we just have to make the clad and the protection outside. And here we just wanted to make it cheap, so we get steel sheets on the roof, and also on the top of the facade like this, like black one. And here in the dome, in the bottom, we wanted to use this technical that we use from Vaucouleurs, from the EHPAD. So only with wood columns and the small blocks tiles in wood coming inside. So we hesitate between this way with this small sheet of steel to maintain, or this way only with only with wood. So that is what we are doing now, and that's it. And I finish my presentation on it. So you can see. I will stop to share my screen, but you can see that we try to experiment and to find a different way to use stone materials to build. And so that's it, Mathieu. It's okay for you?
Perfect. Really nice presentation. Thanks a lot again, Christophe. I was not expecting so much because I didn't want to take so much of your time, and I was asking you to speak about one or two building, but so much different techniques is very interesting. You almost made my lecture from tomorrow, so I'm happy.
Thank you. I prefer to show different technical like this, so it's nice to understand the difference between the different technical.
Yeah, and also I'm really happy that you shared about your last building, explaining post-tension stone construction, because I was not aware that you will work on it, that you were working on it, but it's really interesting to see such building starting now. So thanks a lot, really, for this presentation. And now I will ask to everyone, if anyone has some question, you can open your camera, your microphone, or just write in the chat if you have any question to Christophe. I'm waiting that, yes.
Sorry. I have a question. Also, I will try to open my camera. Anyways, I took some notes. Actually, there was a building. It was, I guess, French, but it's the name of the building like March covered the sun this year, something like that. There was arch. There were many arch, little one, middle one, and big one.
Marché couvert. Okay, the marketplace, Christophe.
Yes, exactly. Actually, my question was more like engineer. As you know, between the corner there is an arch and there is a space between the corners. So, did you understand what I was trying to say?
Not exactly. So you say that between the corners, the four corners of the building, there are some arches, yes?
I am talking about the biggest arch.
Yes.
Between these corners, also under the arch, there is a space. Do you decide this length of the space, or engineer decide the length of it?
The shape of the arch or the
span.
Span, exactly.
Ok, la dimension de l'arche, la longueur de l'arche.
We decided the dimension of the arch. We wanted a building that have 30 meters large. So we get some walls, and we think that 24 meters was a good size. So we proposed that to the engineer, and then we work together to see with them if it is possible, with what kind of stone, what size of stone blocks. You know, it has to be realistic. If you need like a stone blocks 3 meters per 3 meters, it is not possible. So you have to be a little bit realistic. But we had the example of the one of SNBR that was 15 meters large. So that was already very interesting. That was realized. That was a big, a nice example, and that's why it was easy to get more far. You know, it's always like that. One do something, and another one go more far, and then you can experiment with the other guy. And we are, because this this firm, SNBR, is the firm that is building our market. You know, they won the contracts, and they are doing it.
Thank you for the information.
You're welcome.
I had a question exactly about this arch too, Christophe, if you could, because you are using stone to prevent the usage of reinforced concrete too much, but at the same time you are explaining that to hold this arch, then you have a big reinforced concrete beam below. So I mean, I understand for these buildings that it's also a kind of advertisement about stone construction, but in this case, is it really better to use as a stone, or is it the same as if you would use reinforced concrete arch, for example?
Yes, you're right. We need concrete in the ground. But we don't need so much concrete because it is just tension. So we need something quite thin, and we use the technology Fraissinet. That was quite complicated for the engineer to find a good way to maintain this tension. The first solution was a big beam with steel, traditional beams, but we will get like always 1 centimeters movement, 1 or 2 centimeters of movement on the 30 meters. So that's why our engineer proposed to use Fraissinet, which is a kind of only one cable like that. So we make a concrete beam, and inside there is a pipe, kind of pipe like that, and then Fraissinet will come and with a metal steel cable, but very specific and very special. They have they make in research this steel cable, and then they make post tension also on the concrete beam. So, I'll explain that to say that that it can reduce the volume of the concrete.
Yeah.
But we still need concrete. I think that we could have no need of concrete on this building, but we had to make a different size of the arch. I think if it is more vertical, to get effort more vertical, you just go on the ground and you don't need cable, because our arch is very horizontal, so it makes a lot of tension, lateral tension.
Okay.
That's
Thanks
it.
a lot. Thanks a lot for it. Any other question?
I have a question.
Yes, Abdul.
Okay. Actually, thank you for the nice presentation. I was a little late, so if you mentioned, I might not have heard. I couldn't note the building name, but you said about site. There was a seismic problem, and that's why you chose circular plan. And about this building, each of the building blocks are the same. I mean, the plan of the building is circular, and each block has to be angled by corner differently from the normal rectangular block. Is this intervention suitable for every stone? I mean, did you think about this when choosing the stone used, about being suitable or not?
Yeah, you're right. They angled they cut the extremity of the blocks with a small angle like that. That was, you tell me. Yeah, and that was not there was not any cost, any problem to do that, you know, because they extract big blocks, then they cut it in 35 centimeters wide, and then instead of cutting it perpendicular, they just cut it with this shape. But there was no problem to do that at all. and it was always the same angle, so they can put on the machine to get this angle, and then they cut very easily. There was no problem.
Okay.
But we hesitated at the beginning. You see the sugar, the model with sugar, and I thought it could be interesting to get to open the join between the stone, and maybe to get the light coming, and I don't know. But it was too dangerous to do that because of the water. If you start to make hole like that, you get water coming inside the walls, and when it gets in ice, it gets bigger and it breaks the stone. So it was too dangerous. So we just decided to cut in diagonal the extremity of the blocks.
Okay, thank you.
Welcome.
Any other question?
I have no question, but I want to say that it was a very informative presentation, and I really like the way how you design the buildings and how you combine the woods and stone. So thank you. It was very helpful and informative.
Thank you very much. Very, very happy.
I would have another question, Christophe, in the 2 minutes. Yes, it was about, I mean, most of the building you have done until now are building in small town or rural area. What would it change if those buildings would be in city centers, for example?
I think we are more free. We are more. We have more possibilities to build in a rural area because they are isolated building. You don't have to respect the urban harmony of the streets or of the buildings. So I think we are more free in the rural area, and also I think people are more confident to you. They trust you more in a rural area. I think you can more experiment, you can more discuss, you can try some things, and also in rural area they still have the know-how and they still love the traditional way to build. So the traditional way to build with stone, with wood and that. When we did the retired office, the retired buildings, you know, for old people, it was very nice to propose stone because these old people were very in love with the stone because they are like 70 years old, 80 years old, and they remember that when they were young, and everybody love stone buildings and respect these old materials, respect wood, respect stone, and that's why it was nice to easy to propose this kind of nice materials. I think it's nice material. It's reasonable.
Okay, thanks a lot. Thanks a lot for all of this. Mm-hmm. And if nobody else has any question, I think we can thank Christophe for its really informative and good presentation. And I'm really happy that you have been here today explaining these different buildings to the students. And I really hope that slowly also in Turkey, we will be able to see such kind of building with large stone coming out, maybe by you, when you will be architects in a near future. Thanks a lot again, Christophe.
It was a pleasure and good continuation, and you can change the world. Huh? Don't forget that. Huh? You are the new generation, so let's find the new way to do. It's important. We don't have the choice, so we have to do differently, and it is very fun, very funny to do that.